Hey seniors, today we're going to be talking about linear, nonlinear functions, and non-functions in equations, tables, and graphs. Remember, data can be represented in many different ways, but a lot of times you'll see it in the form of a table or a graph, and an equation can be used in order to extend that representation. So I want you to go ahead and write our title at the top of your notes page, and let's remind ourselves what functions are. Equations, graphs, and tables are functions when there is only one output, which is y, for every input, which is x. Write that in your notes page. It's very possible for functions to be linear or nonlinear, and we learned that yesterday. Of course, that's just a refresher. So let's go ahead and jump into some examples with equations. Okay, so anytime you see slope-intercept equations, they're always going to be functions because they will create a straight line where every x value has one y value. So for an example, if I had y equals 2x plus 5, I could substitute in a number for x, let's just say 2, and have exactly one y value. So then I would have 2 times 1 is 2, and 2 plus 5 is 7, so y would equal 7 here. So this coordinate would come out to be 1 and 7, which means that this equation has one y value for every x value. Let me show you some other examples that are always functions as well. Let me go ahead and erase this first. Okay, so another example might actually be y equals 7. Now, this, believe it or not, is a function because if I draw a graph, let's say y is 7 right here. If I draw a straight line across, for any of these values, I could pick a point along this line. Every x value would only have one y value. So if I had, say, this line was negative 1 and 7. And this next coordinate would be negative 2 and 7. The x value, the y value might stay the same, but for every x value, there is only one y value. So anytime you see y equals a number, it's always a function. Let's do another example. Okay, if I had the example, whoops, let me get my pencil back out. If I had the example y equals x squared plus 3. Now immediately when I see that exponent, a red flag should go up in your head that will tell you that this equation is nonlinear. However, this equation is a function because it's okay for there to be multiple x values for each y value, which we just proved with our graph where we said that there was going to be the same y coordinate for every x coordinate, which was absolutely okay. Same thing here. It's actually okay for there to be an exponent because if I were to plug in 1 or negative 1 for x, it'll give me the same y outcome because a positive and a negative squared will give me a positive outcome. So whenever you see x squared, it is a function. Okay guys, let's talk about some ones that are non-examples. And by that I mean some equations that are non-functions. Whenever you see equations like this, always, always, always know that they are non-functions. Remember when we said that x squared was okay in terms of equations being a function? That is true. However, if you ever see y squared, it is never, ever, ever a function. Never, ever. Also, whenever you see x equaling a number, that is never a function because if I were to draw that out on a graph, it would have more than one y value to it. Or if you ever saw x equals y squared, also not a function. So be aware of those. We're going to get a lot of practice in with these through our questions in Educam and also through practice as well. Okay guys, let's move on to tables. Make sure that this is written down in your notes page. Teachers are going to be coming around to check that it is. So when I'm looking at tables, again, these tables are representing coordinates on a graph, which have an x and y relationship. And again, something is only a function if for every x value there is one corresponding y value. So pretty much all I have to do with this table is look at it and see if any of my x values repeat. If none of them repeat, the table is a function. Let's go ahead and write that on our notes page. If there's no repeat, it's a function. If the x values do repeat, then that means that the table is not a function. So if all I have to do is go through and look at my x values, looks like none of them repeat, that means this table is a function. Again, I'm not interested yet in the slope or figuring out if the table is linear. I just want to figure out, is the table a function? Okay, so this one's asking us, determine if the following coordinates represent a function. Whenever I see a line of coordinates like this, I always want to set up an x, y table and just fill it in, and then I can see if my x values repeat or not. Super easy. All I have to do is set up my x, y table, and then I can look at my values easier. So immediately I go through, I look at my x values, -2, 1, 3, 5, and 7. None of these x values repeat. This table, or this set of coordinates, is a function. Yay! Make sure that one's written down on your notes page. All right, let's do a second one with these. Do the following set of coordinates represent a function? Again, let's go ahead and set up our x, y table. We're not going to fill in all these coordinates. We're just going to do the first 5 or so. Again, make sure this example is written down in your notes page. Now, I should be able to immediately look at this table and tell me and say whether or not it is a function or not. Just by looking at my x values, I see that the -4s repeat as x values, which means that this table is not a function. Okay, guys, that's going to be it for me today. Let's go ahead and jump into practice.